Dr. Wallace, thank you so much for joining us here on Health Connection. Our topic is superbugs. It says here, evolving and nasty. Now, we've heard about MRSA. We know about things that are resistant to antibiotics. But explain really what is a superbug and why is a superbug so dangerous?
Well, a superbug just is a bacteria that's become resistant to multiple antibiotics, most of the common antibiotics that we use. So treatment is difficult because the number of drugs available to treat them is very small. So you don't always expect it. I have a personal experience. I don't know whether my wife got a urinary infection when we were traveling, and so they gave her an antibiotic and she didn't get better. So she called in, they gave her another antibiotic, she was having fever, felt bad, still didn't get better. Went to the hospital, got put on IV antibiotics as an outpatient, still didn't get better. But they cultured her urine, and turns out her urine was resistant to virtually everything except one IV antibiotic. She got extremely ill. Here she is, married to a physician. I didn't know why they weren't working until she hadn't been on antibiotics. She didn't seem like a big risk for me. So it touches very close to home, and the risk is very real.
It's easy for us in the 21st century to forget or to have never known that at one time bacterial infections kill people. And we've come to expect you get a bacterial infection, you go to the doctor, you write a script, you get better, all done, no more than a nuisance.
Right.
But that's not the case with bacterial infections that antibiotics won't fix. And we've talked about superbugs on this program before. Recent developments are quite frightening. What's changed?
Well, I don't think anything's changed. The bacteria continue to evolve. If you threaten them with, in this case, different antibiotics, they have available, or some bacteria has available to them, a piece of DNA that makes them resistant to the antibiotic. Now, it may be present in just a few bugs, but if you put this drug or set of drugs out there, only the bugs that have this piece of DNA survive. Or they pick up that piece of DNA by genetic exchange, and then it allows them to survive in whatever environment you're talking about, the nose, the throat, the gastrointestinal tract. That's basically what's happening, and we continue to use antibiotics probably more than we should. We're not developing a lot of new antibiotics, and so the end result is a set of bacteria that are really resistant to most of the drugs we have available. So when you have even one more drug for which resistance appears, we get very nervous.
How does a person get a superbug, and where are they most likely to be found, and how can you tell the difference between a serious infection and something minor like an insect bite?
Most of the superbugs are in the hospital, and they're in people who are hospitalized for long periods of time. They're exposed to a lot of antibiotics, so their GI tract, their gut, is basically just colonized with bacteria that are resistant to all the drugs that they've been put on. So they're sort of a natural environment to select for these drug resistance. But with enough of it around, it's now present in the community. MRSA that we talked about, there's now a community variant, if you will, of MRSA that exists in normal people. We don't know what selects for that.
What is MRSA, just for those that might not know?
MRSA stands for methicillin-resistant Staph aureus. It's a form of Staph aureus that's resistant to the #1 drug used to treat Staph aureus, both orally or an IV. So the appearance of that resistance gene touted a major change in how we approach Staph aureus and how we treat people for it.
You touched on this. A lot of experts claim that the overuse of antibiotics is to blame for resistant bacteria. Is that the only reason superbugs are becoming a problem, or is there more at work here?
There's probably more at work here. For many years, we were kind of in a honeymoon period. Pharmaceutical companies were developing new drugs at a pretty rapid rate, so that if one drug became not useful, another drug would appear. But the pharmaceutical companies have honestly changed their approach, and they're interested in antibiotics that millions of patients will take, and that allows them to make
Right.
money. These drugs that treat superbugs, we're talking about a smaller number of people. You have to do a lot of research and development, and you're not going to make a lot of money with it. So they have just stopped making those drugs. So for the past 10, even 15 years, it's been that long since we've had a new good antibiotic to be used for treating these organisms. So they continue to evolve in terms of their ability to fight off antibiotics, and we don't have any new bullets to shoot at them. So it becomes more and more dangerous, both in the community and in the hospital. We get nervous. You come in, you say, how do I tell the difference whether I have a regular bug or a superbug? Well, we can't tell. So what happens is you get more antibiotics than you probably need, and you get more powerful antibiotics because we're worried about those superbugs, and that just makes the problem worse. So we do cultures, we do find out what the drugs are sensitive to. That takes 2, 3, 4 days. That's 2, 3, 4 days you may be taking a powerful antibiotic that you don't need. And that is happening both in the hospital and out of the hospital. So we are contributing to the problem in addition to the skills of these organisms in surviving. Remember, they're billions of years old, at least millions. They've learned how to adapt to incredible changes in the environment. It's too hot, too cold, chemicals in the environment, petroleum products in the environment. Somewhere out there are some DNA pieces that allow them to survive, and they've just become more and more prevalent in the regular bacteria that we run into.
You touched on this. Patients now routinely expect, if they don't feel well, when they go to the doctor, they expect or even demand an antibiotic prescription. And they put a lot of pressure on the physician. What's it going to take to educate physicians and patients about when and when not to write a script for antibiotics?
It's a tough issue. I think when patients say they have a fever, or a cough, or a runny nose, they've made the decision in their mind that they're a candidate for an antibiotic, and they go to the physician because they're ready for an antibiotic. And so when you say, I'm sorry, I think you have a virus, an antibiotic can cause harm, I'm not going to give you an antibiotic. What? No antibiotic? As if you knew that you needed one. And so, gee, you're thinking, well, this is one of my regular patients. I mean, and to explain why you're not going to give the antibiotic takes much longer than writing a script. So we write a script and move on to the next patient.
And there's probably some placebo effect at work by writing the script.
That's right. You get better with and without the antibiotic. Your virus is going to last 4 days. And if you don't take the antibiotic or do, and if the timing is right, you say, man, that was a great antibiotic.
It worked.
It worked. Little did you know that if you didn't take it, you'd gotten better then too.
Be better in 7 days with the antibiotic. You're good in a week.
That's it.
There you go.
That's it.
For only the 4th time in history of the United Nations General Assembly, the UN is meeting to discuss a health crisis. They're going to meet about superbugs. The other 2 most recent health meetings, to give you some idea of the seriousness at the UN, were HIV in the 90s and Ebola in 2014. Is it going to take a worldwide effort to find ways to beat superbugs? Absolutely.
There's another example that most people don't know about, is that tuberculosis is a disease that affects a lot of people in the third world. I mean, health conditions are not the best, crowding is bad, not a lot of drugs. People with tuberculosis are identified late, so the disease is spread fairly readily. We have only a limited number of drugs, and in some of the countries that have very poor public health situations, they've just given out the drugs, created a superbug out of tuberculosis germ. Well, the problem with that is that no pharmaceutical company is going to invest in a drug for tuberculosis. There's just no money to be made in it. So we, the government, we the people, because we pay taxes, have contributed millions and millions and millions of dollars to develop new drugs for tuberculosis. And we have some good ones that are either on the table or already in use. I don't think there's much other answer for these drugs than the same answer. It's going to require multiple sets of governments, multiple different countries contributing an effort to identify, to encourage, to develop these new drugs. And you could do that. You could provide financial incentives, for example, to pharmaceutical companies to work on antibiotics. That's a decision that has to come from the government, from the FDA, and we haven't done that. But that's one of the things that has to happen, or things are just going to get worse.
A topic we have covered with one of your colleagues for treating cancer is immunotherapy. And there's some current research showing that there's promise in immunotherapy with respect to bacterial infection. What do you think? What's your opinion?
Well, vaccines are actually immunotherapy. We give you a piece of whatever the bacteria or virus is, sensitize your immune system, so when you see the real bug, you're prepared. Influenza is high on the list. We have a number of other vaccines. There are some bacterial vaccines that are currently used. The difficulty with the vaccines is that it's very organism specific, so that it works only for one organism. And for some organisms, vaccines are very complex and don't work very well. We've been working on an HIV vaccine for 20 years. We've spent billions of dollars worldwide. And we've got some maybe candidates on the list. That's a lot of time and effort. So some drugs are better than others. The ones that are left are generally the ones in which fairly simple vaccine immunotherapy is not going to be effective. So it's still a possibility. It's very selective. Finding some immunotherapy that turns on the immune system, that fights off all bacteria, is not realistic.
A lot of times in research and in science, the solution to problems comes from unlikely sources. You stumble upon them. Some research to combat superbugs is being done through animal testing, while one recent report finds a possible solution inside our own noses. Explain that, and what do you think of that, and where do the promising answers lie?
One of the survival mechanisms for bacteria is, so you live in this particular place like the nose, well, there's lots of other bacteria there that are competing for the same nutrients in the same place inside the nose. So how do you beat the other guys that are in there? They make chemicals, which we've known about for many, many years. It's a name I won't mean much, but it's called bacteriocins, and it means things that kill bacteria. So they actually make a substance to which they are resistant by their DNA, but the bacteria around them are not. And so what they found, we haven't been looking for these for years, but what recently has been done is to take some bacteria and to expose it to more serious bacteria and to show that they made something that actually inhibited the bacteria. We've been largely dependent on synthetic drugs in recent time periods, but the initial antibiotics were all based on taking bacteria and looking for substances. Penicillin, first example, was a bacteriocin. It was made by the bacteria to protect itself against all these other bacteria. But it's a line of research that we haven't been doing for perhaps 20 years. It's worthwhile to go back and start looking again, and that's what that represents.
Aside from, as you alluded to earlier, staying out of the hospital, what can we do to prevent getting a superbug in the first place, and is acting quickly when we notice something that looks serious, is that the key to recovery?
I think physician judgment and some laboratory tests help us decide if this is minor or serious. It's beyond the patient. So the patient has to make some decision. Gee, I'm more sick than usual. I have more fever than usual. They've been warning me about this in the newspaper, in the media. Then you decide to go to the physician, and then he has to use his judgment or her judgment. What's most likely here? What's in the season? Is it likely that they have this? Is it more likely they don't have something serious? Again, we just don't have a way to recognize whether the bug that's causing your disease is extremely drug resistant, a superbug, or it's just a regular bacteria that's not very resistant. MRSA, this is not more aggressive than regular Staph aureus, but the drugs that we typically give, penicillins, drugs called cephalosporins like Keflex, which are readily available and very financially advisable to use, don't work. So it's a very painful situation for patients because they're going to have to be willing to go with what the doctor says and not press him to get antibiotics. And because you arrive at the office doesn't mean that you need antibiotics. But the doctor has to be willing to take the time to explain to you why he or she's not giving you an antibiotic and what to do what sort of warning signs you should have to go back to the doctor if maybe they're not right about the judgment, because it is a judgment. And that takes time, and like we said, that's not easy to do when you have 30 patients out there waiting to be seen in the office.
Very well. Doctor, learned a lot. Thank you for your time.
You're welcome.